Okay, let's take a look at some common gases and their abundance. If you look at the periodic table, most of the elements are not in a gaseous form at room temperature and normal 1 atmosphere pressure, just a handful of them. Here they are shown in a list. A lot of them are in fact bimolecular, so hydrogen, nitrogen, chlorine, things like that exist as Cl2. There's also lots of compounds that exist as gases, things like hydrogen fluoride, sulfur dioxide, nitric oxide, ammonia, things like that. So they're just some of the common gases you'll be working with. The composition of air is something that might surprise you a little bit. Look at the giant percentage of air that is just nitrogen, relatively inert gas. Large percent of oxygen, almost 21%. The third most abundant is not carbon dioxide or something else you might predict. It's actually argon gas. And then that remaining 0.04%, such a small amount, is where things like carbon dioxide are. And in fact, most of that remaining amount is carbon dioxide. And yet, it's less than 0.05% of the air, implicated for so many things, including global warming, and yet such a tiny amount. Excuse me. And there's hydrogen, nitrogen, fine. It's also a nice thing to just be aware of how the pressure of air varies with height. So at sea level, we define it at 1 atmosphere. You know, when you look up data, it's hard to find atmosphere data because weather people and other scientists love to deal with either inches of mercury or millimeters of mercury or pounds per square inch or kilopascals. But atmospheres is a very convenient unit to use since plain old sea level is 1, so you can compare things so nicely. It's also the SI unit that we use, for example, when we're doing the ideal gas law, things like that. So you have to go up to about 4 miles, 22,000 feet or so, to have it go down to half an atmosphere. And at 10 miles, it goes down to about 2 atmosphere. If you want to see way too much data, that's reflected fairly closely here, although the numbers for atmospheres, if you do take a look at them there, are a little bit lower. So if you're at the summit of Mount Everest, which is 29,000 feet, there's 30,000 feet right there. You're dealing with less than a third of an atmosphere, so very, very low pressures when you get up high. Those are some fun facts about gases.